All right, welcome back. I hope you're having an awesome time so far. Our next speaker is Zayd Enam. He is the CEO and co-founder of Cresta. Please join me in welcoming him to our virtual stage.
Thanks so much for having me here. Cool. Yeah. I hope everyone's having a great session so far and great conference so far. I'm here to really talk about how artificial intelligence can be used to help amplify expertise. But before starting there, I'd like to give you a quick background on what that even means and what the whole purpose of artificial intelligence is. So artificial intelligence has been a tremendously powerful technology that's been used in all kinds of scenarios, from being doctors with skin cancer to self-driving cars to education to all kinds of work in the office. And what we've identified and what we realized that there's really two ways to look at artificial intelligence. And the one way that we'd say is a way to look at artificial intelligence is what I would call a lazy way, which is like, what are the things that we can do right now in the world? What are the things that we as humans do? And how can artificial intelligence be used to automate those things? So take, for example, something I could do on my computer or something I could do in terms of an existing process and say, I'm going to build artificial intelligence that will automate that process. And that's something you've probably seen, stuff like robotic process automation or automation software that basically uses artificial intelligence to automate the existing process. But the thing is, like, that's a lazy view of artificial intelligence because the impact and potential of AI is so much bigger than just automating existing processes. Artificial intelligence at the fundamentals is a building block technology. It's a technology that unlocks new capabilities that we, for example, now would never even be able to imagine. And so thinking of artificial intelligence, that lens is really how to use humans and artificial intelligence together, both humans and AI, as building blocks to unlock new capabilities that weren't even possible before. And that's really the lens that we view artificial intelligence at Cresta. But that's the lens I'd encourage the whole field and industry to look at. Or what are the things that weren't even possible before that we could use artificial intelligence to go do? So one example of this, as an example, is you might think that, take the case of a self-driving car. So there's a case of trying to automate what an existing driver does, and what are the things that an existing driver could take a car from one place to another. But the power of the artificial intelligence technology in the case of a self-driving car is that it can learn from a fleet of drivers. So it can learn from drivers who've driven in cases where there's all kinds of rough terrain or really weird scenarios. So every time a car is learning from example where there's an accident or some kind of special scenario, that becomes something that not only the car learns, but it sort of goes to a whole brain that's learning from all those examples. And then that knowledge can be distributed across all cars that are built. And that's a unique aspect of that technology, where it's not just sort of automating the driving part of it, but it's making people better than ever before, because they're all learning from the examples of these rare cases that happen only very occasionally. And so like that's one example of artificial intelligence used in the context of a self-driving car. And you can think of that as applied to historical technologies as well. So when the first phones came around or the first computers came around, people weren't thinking of that technology through the lens of how do we automate things that a human does right now. When the first phones came around, what they made possible is they made it possible to basically transmit your voice at the speed of radio frequency, at the speed of basically light, to from one place to another. And that was a fundamental capability that just wasn't even possible before. And so just like the phone is a building block that's made new capabilities possible for us, or computers, which have been described as bicycles of the mind, where it's not just automating basically bookkeeping or tasks that we were doing on pencil and paper, but more so as a building block to unlock entirely new things like creative design and blogging and writing and all these kinds of applications that we just couldn't even imagine in the age of pencil and paper. Artificial intelligence is going to be the same way, where you don't think of it as a technology that, hey, I have an existing mundane, repetitive process that I want to go automate, and that's where AI can impact. It's really how do you combine humans and AI in very unique ways to sort of make one better than the other. So this you might think that this is a relatively new field, but it actually has a really, really sort of rich history. So actually the very earliest examples of this were in chess playing games. So the identification was that algorithms are built to play chess just by computers versus humans. For a long time, humans handily beat out computers. And it wasn't until IBM's Deep Blue that we had the first sort of algorithm that could beat a human player in chess. But actually in the middle, there was actually these algorithms that were a combination of humans and machines, where it was a technology that together could perform even better than the best machine. And so that was a very powerful impact and had a really big impact in terms of being better than any of the single computer, any of the single humans. And together, what happened, the way it worked was that the AI would be able to predict sort of steps ahead much more than a human could. And the human could focus on strategic sort of where they want to go, and the AI could come back with probabilities of how each piece would lead to success. And so that kind of combination was leveraging the strengths of artificial intelligence, leveraging the strengths of humans. You see the same thing applied to diagnosis as well. So if you look in healthcare, it turns out if you have a panel of these kind of algorithms that work together, so you have if you're trying to diagnose a certain type of cancer, you can actually have higher accuracies with a panel of these algorithms together where each is trying to detect a different type of cancer, and you take the sort of combined vote of all those algorithms and you compare that to a human, and actually initially they're about the same, but if you combine them all together, so you combine what a human can diagnose and combine that with an algorithm, and then you look at their votes together and then use that to basically break a tie on whether a cancer is malignant or benign, you get much higher performance. And the reason is because as humans, we've built pattern matching in terms of being able to look at a particular lesion or tumor. And that's something that we can do that gives us some strengths. But computers have another strength where they can look at hundreds of thousands of images or MRI scans or radio scans and be able to look at data-driven analysis and insights. But they still have gaps where they might be really good at that particular tumor because it appears many, many times in the data set. But let's say there's a new tumor that comes along that's entirely new. That's something the algorithm would never be good at because they've never seen that in the data set. But that's something that a human would actually be good at because it would have generalized what a tumor means based on some basic concepts. And so that's really another example where the combination of humans and AI together become more effective. I think the same thing applies to conversations. And we've seen this so many times in times of AI applied to work, AI applied to the office, AI applied to people. Like time and time again, we try to apply artificial intelligence to very complex things that we do on a day-to-day basis. And we try to use it for those kinds of applications, but it always falls short. And so the opportunity is not just to sort of look at it myopically in terms of what can AI do that a human does right now, but how do you take the strengths and advantages of artificial intelligence and leverage a human alongside it to make that more effective or more sort of effective together. And so there's really three things I would say that really are the basis of this and the basis to look at artificial intelligence in this space. So first of all, it has to be observable. So in the sense that you have to be able to understand what's happening and what it's doing. And that requires you to sort of have some kind of visibility into how it works. So it's not just a black box system. And that becomes really key because if you're going to work with a teammate, think of AI and humans as teammates together, would you want to work with a teammate that sort of goes off in the dark, comes back with a result, and you're not really sure how they got there? Or would you rather work with someone who's communicative and collaborates and works with you together? Same thing applies to AI. And so you need that visibility in the system. The second thing is it has to be constantly iterating and learning. So that's another key piece to it, which is like AI has this tremendous leverage advantage where it can take big data sets and extract patterns and insights from those data sets to make predictions. But that's only as strong or as weak as the data fundamentally. And oftentimes the challenge in these kinds of algorithm systems is the actual underlying data. So if you can build iterative ways to edit, update, upgrade the data, clean the data, that's really key for these kinds of systems to be able to work effectively in tandem with humans. And the third thing is like really think about and be conscious about what is the interaction between the human and the AI. There's certain ways where you can sort of build AI to be non-annoying, non-irritating, but actually helpful to the person and helpful to help them achieve the job they're trying to do. And there's other ways to build interfaces and interactions that are just very annoying and very irritating. So one example is this is like sometimes the AI is going to be wrong, and that's just going to be the case. Now, in that case, is it harder or easy for the human to overcome the prediction or overcome the suggestion made by the AI, or is it very difficult for them to get out of the way? And that's one example of a kind of interaction that's key to get right, where what happens when things aren't exactly correct, what kind of interaction do you give to the human? But those are three kinds of examples: being observable and not just a black box, being collaborative in the sense that if a human gives a suggestion, being able to use it or not, and being iterative in the sense that as things progress, as data progresses, being able to clean and keep that going. I hope that's useful. I think those three principles really help us build effective AI that combines the expertise of humans and the expertise of AI together. And I hope they'll serve as principles as you think through applications of artificial intelligence in your business.
Awesome. Thank you so much. Thank you for sharing these insights with us. I know the audience is giving you a huge virtual round of applause.
Thank you so much for the time and for the ability to present.
Of course, it's our pleasure. For the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and take some time to check out our amazing AI exhibits. Thanks so much, and we'll see you around.